All right, so the topic of today's lecture is sampling. So sampling is all about getting data from a larger group, a larger population. So for example, suppose a new Star Wars movie comes out and we want to know, what do people think about it? Is it good or is it bad? We can't ask everyone in the population, in the movie-going population. That's millions and millions and millions of people. We just don't have the resources to do that. So what we do instead is we take a sample. This means we find a smaller group of people, ask them the question, and hope that their answers are reflective. They tell us something about the population as a whole. So in other words, what we're really interested in is, what does the opinion of the sample say about the population? So we've used a couple of words here. Let's just make those more precise. The population is the set of things being sampled from. Okay, this sounds a little circular, but I think it makes sense. The population is the bigger group, and then we draw a sample, which is a subset of that population. So the population is the thing that we're choosing people from or things from. So for example, all moviegoers, that might be the population. Our sample is maybe 10 people who watch the movie. Another way, or another example of a population and a sample is one that you might not think of, but for example, suppose I roll a die. The population in this sense is the set of 6 faces of the die. The sample is what I see whenever I roll the die. So I can use this terminology of a population and a sample in a familiar kind of probabilistic experiment, like rolling a die or flipping a coin. So when we're talking about samples, there are really kind of 2 types of sample. The first being a deterministic sample, and the second being a probabilistic or a probability random sample. Okay, typically we prefer a random sample, but sometimes we don't really have a choice. So let's talk about the difference between the 2. So a deterministic sample is one where I get my subset of people in a way that doesn't rely on any sort of randomness or chance. And we'll talk about some examples of that in a second. But one example is, if I sampled the people in my class, just taking everyone whose last name was, started with an A or a B or a C. There's no randomness there. Once I consider my class being the population, my class is the population, and it's fixed, there's no randomness in picking last names by letter. On the other hand, you have a random sample. This is a sample where some chance is involved, some randomness is involved. And formally, the definition of a random sample is one where I can calculate, or I could in principle calculate beforehand, the probability of selecting every subset of the population, so every group. In a random sample, it doesn't have to be uniform or fair. Not all individuals need to have an equal chance of being selected. It just has to involve some chance. So let's see some examples of these. So an example of a deterministic sample, like I said, I want to sample students in my class. The way I'll do it is I'll take 50% of the students, but I'll do it alphabetically by last name. So I will sort my roster, my class roster, and then I'll just take the top half. There's no randomness here after I fixed the class, the people in my class, okay? So sometimes people get confused. They might say, well, isn't the class kind of random in terms of who decided to take the class? I'm assuming here that the people in the class are fixed, it's set, and now I am sorting, taking the top half. There's nothing random there. It's always going to result in the same sample over and over and over again if I repeat it. On the other hand, suppose I want a sample of my students, maybe to survey them about what they think about the class. One way I could do it is for each student in the class, I flip a coin. And if the coin comes up heads, I keep that student in my sample. If it comes up tails, I do not include them in my sample. And so this is purely random. Okay, if I do it over and over again, I'm going to get a different sample every time. So that is intuitively the difference between a deterministic and a probability sample, or a random sample. Okay, so here's another example of a probability sample. I have a population of 3 individuals, A, B, and C, and I want to select 2 of them. Okay, so here's one way of doing it. I'm going to choose A with probability 1. That means I'm always going to take A, and then I'll choose between B or C based on a coin toss. I'll flip a coin. If it's heads, I'll choose B. If it's tails, I'll choose C. This is kind of a weird way of selecting people. One of the interesting things about this is not everyone has a equally likely chance of being selected. A is always selected, for example. But it is a random sample. It is a probability sample because I can calculate the probability of each outcome. So what's the chance that I get A and B in my sample? Well, that's a half. The chance of AC is also a half. And the chance that my sample is BC is 0 because A is always chosen. So since I can calculate these probabilities, it is a probability sample. And if I repeat this over and over and over again, I'll get different results every time. So let's work with some data. Let's work with a data set of movies. So here I have 200 movies. I think they're the top movies on IMDb. I have the studio of each movie, how much money the movie made, how much money the movie made adjusted for inflation, and then the year that the movie came out. So one of the ways that we can take a sample here is with the take method, and we haven't seen this much yet, but what the take method does is you give it a list or an array of row numbers, and it'll return just those rows. So if I want row 3, row 5, and row 8, I can .take with this list, and I get back just those rows. Okay, so this is a sample. It's a subset of my population. My population here is the set of 200 movies. My sample here is the set of 3. This is clearly a deterministic sample. If I repeat this over and over and over again, I'm going to get the same thing. Okay, so what if I do a query? I select movies which have "and the" in the title. That's clearly a deterministic sample. If I repeat this over and over again, I'm going to get the same answer. So what about this? If I start with a random number, so I draw a random number, okay, and then I take every 10th row thereafter. So I draw, for example, 21, and then I take row 31, 41, 51, and so forth. Is this a deterministic or a probabilistic sample? So this is a probabilistic sample, even though it's misspelled there, because the answer is different every time. And in principle, I could calculate the probability of seeing each set of movies. Now, any row is equally likely to be picked here, but that's not true for groups of rows. All of my results, every time, so I'm going to run this over and over again. We'll see some patterns here. So here's my first set. I'm going to get this again. Okay, let's see if we can get that avatar. So notice that it goes Avatar, E.T., Frozen, Transformers. And if I do this again, okay, I get the same thing. Let's run it again and again and again. Let's get back to Avatar. There we go. See, it's Avatar, E.T., Frozen again. Every time, there is randomness here, but any set, including Avatar, has to include E.T., Frozen, and Transformers because I have a fixed gap of 10 between every row thereafter, after the first row. So every movie is equally likely to be picked, but sets of movies, some never will be seen. For example, I'll never see Avatar and the movie that comes directly after Avatar in the table. So how do we do random samples with tables? It turns out there is a table method which helps us out here. It's a new table method we haven't learned yet called .sample. So this works. It's very straightforward. So if I want to take 5 rows from my table with or without replacement, I do this with my table.sample and then tell it how many rows I want. So for example, I'll take my top movies, I'll sample 5 of them, and I get 5 random movies back. I do this again, I'll get a different set of movies. This sampling is done without replacement. So remember what that means. It means that once I take a movie out of my table, I do not put it back in. I cannot select it again. So you will never see any duplicates in this set of 5. You'll never see the same movie twice. On the other hand, I could sample with replacement. The way that we do that is with the replace equals true keyword argument. So I'll say replace equals true. I get a sample back. Let's see. I don't know. I think we'd be kind of lucky to see the same movie twice here because we have 200 movies. But if you keep doing this over and over again, eventually you're going to see some duplicates because we're sampling with replacement. Once I take a movie out, I'm putting it back in and I can select it again. So before we move on, it's important for us to mention a popular type of sample or a popular type of way that sampling is done that has some drawbacks, and that is a sample of convenience. So a sample of convenience is where we just sample by taking whatever comes to us, whatever walks by, for example. And the problem with this is that it isn't truly random, okay? Because we can't calculate ahead of time what the probability is of seeing any particular group in the population. Okay, so let me give you an example. So a sample of convenience could be a voluntary internet survey. So for example, suppose apple.com puts a poll up on their front page, which is like, is your next phone going to be an iPhone or an Android? I mean, that's not representative of the greater population at large. It's representative of a very biased sample. The word we use is biased. The people coming to Apple's website are probably interested in Apple products, interested in iPhones. They're going to respond with iPhone at a higher rate than the greater population. This is a sample of convenience because we didn't really have to go out and find these people. They just came to our website. Another sample of convenience is if you stand on Library Walk and you ask the people walking by. You're likely to get a very biased sample here. Suppose you're interested in figuring out people's opinions on nuclear power. And if you're standing outside of a class on nuclear engineering, everybody walks out of that class, they're going to say, yeah, I think it's a great idea. If you talk to other people, they might think it's not a great idea, depending on where you stand on Library Walk. Another example is just the first 100 visits to a website after an email campaign begins. So I send out an email blast saying maybe I'm trying to promote my candidate for office, and I say, come to our website and donate. The first 100 people who click on that link are probably super excited about the candidate. So whatever poll I have them fill out, their answers are going to be very biased. Samples of convenience have their place, though. I mean, they're really easy to do, of course, because they're samples of convenience. And for that reason, they're inexpensive. And I guess for those two reasons together, they're probably the most common type of sample. It's probably the most common way that studies are done. The cons are the results won't generalize to the population as a whole, most likely. Okay, so think again about my poll on Apple's website. That's not going to generalize to everybody because the results are likely biased. So it's just important to keep in mind that whenever you see a study, you want to ask, how did they collect the data? And if it was a sample of convenience, then you want to be kind of skeptical about the results. So here's an example which kind of drives this home. Suppose I wanted to understand something about the age of the customers at my casino. And how I do it is I go in on a weekday afternoon and I stand by the door and I look at the people who are coming in. And I take a guess at their age, or I ask them their age, and then I get a result at the end of the day. Now, the problem with this is that who's going to a casino on a weekday afternoon? It's people who, are probably retired. They don't have to go to a job. So you're going to get a sample which is skewed in terms of the age. You're going to get a lot of older people. So again, a sample of convenience is likely to give you a biased result.